Okay, so the final section of the lecture is going to be about analogy learning. And this is an application of COBALT and the principle of the dual mode of learning, that we can learn and control our actions unconsciously. The key concepts for working with this approach is firstly to be aware of the difference between declarative and procedural knowledge and how that is understood when using analogy-based learning, and then to talk about techniques for applying analogy as well. So declarative versus procedural knowledge. With traditional approaches to learning that we've come across so far, and if we recall the Fitz and Posner's model, learning involves a change from conscious or explicit modes into unconscious or some implicit mode of control. So we go from a verbal cognitive stage to an automatic control stage, where the rules and processes that underlie successful control become unavailable to our consciousness. And we can characterize these phases as follows. So the verbal cognitive phase is characterized as having controlled processes, processing high amounts of attention being placed. It's explicit, so we're conscious and we have verbal control over what we're doing. We amass declarative knowledge, so we're able to say how it is exactly what we do. It finally relies on working memory and a serial processing approach where we go through a series of linear stages. And this learning process proceeds into a automatic stage over time. Here we go from, once we're in the automatic phase, our control is characterized as an automatic process which requires a low amount of attention to be placed on our action. It's implicit, so it's unconscious. It's become proceduralized, so we're no longer able to describe the rules of how we move. And we don't need working memory, and we can operate a range of different actions at the same time, so we can multitask. And the mode of learning that we've talked about in COBALT, however, is different. In this case, we have this build-up of verbalized rules that occur when we learn things consciously. Whereas when we learn things unconsciously, we don't learn those rules. We can't state what they are. And this is independent of what stage of learning we're in. So in COBALT, it takes a parallel view where explicit learning is accompanied by implicit learning and vice versa. And the only claim that Willingham makes is that implicit learning can continue for a longer period of time. So it seems to have you can get more out of it the longer you practice. You can get more implicit gains over time. And there are a variety of methods that exist for promoting unconscious learning or promoting procedural knowledge as opposed to declarative knowledge. And these techniques all have the same aim. They have that aim of preventing the accumulation of verbalizable rules about how an action is performed. And with analogy learning, the idea is we use a metaphor that summarizes a series of separate rules into a single consistent whole or a chunk. And the example might be, one of the example I'm using here is Okay, so if we wanted to teach this technique of throwing a basketball, where we have a particular sort of complex movement with our wrist, and this is something that's beneficial um, as something to develop in basketball, we could describe and make explicit the rules around how to do this for a learner. An alternative is we could use an analogy. So this idea of putting your hand into the cookie jar gives the impression of that movement, or a way of performing that movement, which has a series of steps involved, but it's summarized using this metaphor. And this metaphor prevents the individual accumulating verbalizable knowledge about all of those steps and how they relate to one another. Other approaches that we've come across include dual tasking. We've heard about dual tasking. Dual tasking can be used to also prevent the accumulation of explicit knowledge. So if we learn a skill while also performing some other task, this distracts us from the, let's call it the primary task that we're trying to learn, so that we don't have the room in to build up verbalizable, rememberable rules. Another approach is called errorless learning. We'll learn about that in week 7. And this is a type of practice where the individual isn't allowed to make errors during practice. And so they don't get caught up in a process of hypothesis testing because of this. And then finally, there's other techniques involving constraints. So you might modify tools and environments in order to encourage particular behaviors without the person being aware of what it is that you're trying to facilitate. And I was very impressed last week with the focus of attention task. A lot of people were using constraints in order to facilitate a particular type of attention. And this is something that you could do as a coach without telling your athlete why it is that you're doing it. And you'll find that you'll be able to make emerge a great range of behaviors using these techniques without needing to verbalize any of your reasons why. So analogy learning, let's just briefly go over the history of it and what it means. So it's otherwise referred to as heuristic instruction. The idea here is we are trying to convey higher order relationships amongst rules of a concept. Analogy learners can apply that concept described by the analogy, but they otherwise can't answer questions about the rules that underlie the concept. And this is a defining characteristic of implicit learning, being unable to actually state what it is that underlies how you do what you do. And so this is a technique, analogy learning is a technique that's akin to chunking. It's some sort of a biomechanical metaphor that allows information to be presented to the learner in a single chunk or bundle of information rather than separate bits of information, which might be described as a traditional mode of instruction and coaching. So rather than having the learner manipulate large, unwieldy amounts of information in working memory in order to control how they move, the individual only needs to manipulate one single information-rich chunk. And it's something we talked about in week 1 is supporting pattern recognition. And this same idea is being used now to inform how we convey information to a learner to try to use to support their performance and learning. So the case study for this week is a paper by Liao and Masters. And in this study, they compared 3 different techniques to support learning. They compared an implicit analogy group and an explicit learning group while practicing learning the topspin drive in table tennis. So these three groups, the explicit learning group, what they did during practice was learn 12 explicit rules that were written down for them. There was an analogy learning group which used a right angle triangle analogy, and then an implicit learning group which would generate a random letter at the beat of a metronome. And to go over the analogy, what the analogy was, participants were shown this image of a triangle with a racket going up the hypotenuse, and they were told to strike the ball while bringing the bat up the hypotenuse of the triangle. And they had a target region on the other side of the table tennis court where a 5 was awarded. The full maximum points was awarded during practice under retention or under transfer when the individual struck the ball in this 5 area. And then there were less points for at least just getting the ball on the other side. They learned this task, this topspin drive, across 300 trials of practice. They were then asked to verbalize the number of rules that they could come up with for how they performed this task. They then performed a transfer test, which involved doing the topspin drive across 50 trials while counting backwards from 1,100 backwards in threes, and then there was a retention test. So let's start with the verbal protocol because it's very important for showing that we have some implicit learning as opposed to explicit learning. And the average number of verbalizable explicit rules for each group is shown on the y-axis, and each group is then presented along the x. So the analogy learning group on average had just under 2 explicit rules that they could come up with related to how they did the topspin drive. The implicit learning group slightly less, and the explicit learning group significantly more rules were identified. In terms of the results during practice and transfer, what it showed was that along the x-axis we have the training blocks, along the y-axis we have the score that they're achieving during those training blocks in terms of where they hit the ball on the target zone. And the analogy group is presented with triangles, the explicit learning group with squares, and the implicit learning group in circles. And what we see is the analogy group has slightly better performance already early on, and by the 6th block of trials is already performing better than the other 2 groups. Under retention and transfer, the analogy and implicit groups perform more or less equally well, and there's no significant performance detriment, whereas the explicit learning group showed a drop in performance under transfer and a boost in performance under retention. So the main difference between the conditions was their performance in the transfer condition, this condition where they count backwards in threes. So just briefly to show, so this study shows that the analogy condition supports learning as well as transfer. It also shows that it supports implicit learning, the learning where you're not aware of the rules, the verbalizable rules that underpin your skill. In a follow-up experiment, experiment 2 in this paper, they then went on to compare an analogy and explicit learning groups in this same task of learning the topspin drive, but they included a different type of transfer test, which they called a stress condition. So the way this worked is participants learned across 5 blocks of training. Again, the same task of hitting to a target region on the table turns table. And prior to the stress condition, so in block 6, participants in the analogy and explicit groups were told that they were currently performing at a lower level than was expected by the researchers. So this was intended to cause some sort of performance anxiety in the participants. In the analogy control and the explicit control groups, there was no stress provided. So this just reflects more practice. And one of the important findings to note is that all the participants who were given these stress instructions, they also reported experiencing high levels of anxiety. And what's shown is that the explicit learning group, they show a slight reduction in performance in the stress condition. And whereas the analogy group shows a modest increase in performance under stressful conditions. And it's interesting to note, so this is very interesting findings, to find that the analogy condition somehow protected the participants from this stress. And there's different possible explanations for this. The two that I think are most straightforward, the first one follows on from what we learned last week. So it seems that the analogy group showed a better capability to maintain attention under this stressful condition. And this might have been because, or should have been because, they're not using verbal rules during the session. So they've got more cognitive resources available to them in order to maintain their attention on the task at hand and to deal with the stressful situation. So their performance remains automatic and uninfluenced by any verbal control that they might otherwise have been able to exert if they learnt explicitly. And the other alternative option is that the explicit group either regressed back to a verbal cognitive stage, and that's why their performance deteriorated. So this idea is that would require that the explicit group did indeed progress from a explicit to a more implicit way of controlling their skill, and then under the stressful condition they reverted back to their to controlling their skill using verbalizable rules. And this meant that those resources that they're now using to control their skill is not able to be freed up to deal with the stressor or of the pressure placed on them during that by the researchers. Okay, so that's it for this week in terms of the lecture content. So the final thing I want you to do now is reflect on this question of, should you be made aware of how we perform skill in order to learn, and why? After going through that question and reflecting on that, take the time to reflect on the 3 questions again to see where you're at after going through the entire lecture. And then, if you haven't already done so, make sure to read the mandatory readings and optional readings for this week. Be sure to read up on the Liao and Masters paper and prep for our online lab. And I'll look forward to seeing everybody this week for that lab. Also, you've got your final vlog video to prepare for your submission, which is going to be due on the 15th of September next week. So make sure that you've gotten all your vlogs done and ready to go for next week, as well as answered all of the case study questions for each week associated with that assessment. Okay, so looking forward to seeing everybody. Final thing you can do is to check your understanding is to work through these learning objectives posed as questions to help you prepare for that final exam. Okay, I'll see you in the labs this week.